Okay, this question is quite tricky. We need to decompose the rational expression 5x squared plus 16x plus 17 over 2x cubed plus 9x squared plus 7x minus 6 into partial fractions. Now, the first step is to look at this denominator and see if we can factorize it. If we can factorize that into hopefully 3 linear factors, then we should be off to a good start. So what we're trying to do, so I don't know, let px equal 2x cubed plus 9x squared plus 7x minus 6. So what we're going to do, we're going to use the factor theorem. If you think, recall the factor theorem, if p of a equals 0, that tells us that x minus a is a factor of p of x. So we're going to use the factor theorem. We're going to test certain values. If we can find one factor, then we can divide by it. So the way you think about finding factors, so say this thing was 3 factors. If you think about how things work, you might have like some x terms here, I don't know, maybe 2x here and an x, something like that. And here you're going to have numbers. So these numbers, if you think about how this term is arrived at, it comes from, in the end, the number is going to come from this times this, and then you're going to times the result of that by that. So basically, these 3 numbers multiplied together will give you this minus 6. So if you're not sure what to guess, you want to think factors of 6 and try positive and negative. Okay, so I'm probably going to start by trying 1. To be honest, I normally start with 1. So p of 1, well, it's 2 times 1 cubed, so that's 2 times 1 cubed plus 9 times 1 squared plus 7 times 1 minus 6. Now, if it isn't going to be 0, you can move on straight away. So 2 times 1 cubed is 2 plus 9 plus 7 minus 6. I mean, that's definitely not 0. So if we were to try minus 1, well, this wouldn't change. These two might get a bit closer. We could try p of minus 1. So that would be 2 times minus 1 cubed, which would give you minus 2, plus 9 times minus 1 squared, which is not going to help, still going to be 9, plus 7 times minus 1, minus 6. So minus 1 cubed is minus 1, times 2 is minus 2. 1 squared is 1, times 9 is plus 9. Minus 7, minus 6, so it's not far off, but so the minus 2 and the minus 7 make the 9, and then minus 6, that makes minus 6, which is not 0, so we've not found a factor there. If we try p of, so I'm now still looking at factors of 6, I'm going to go up to 2. If we try 2, so that's going to be 2 cubed minus 9 times 2 squared plus 7 times 2 minus 6, well 2 cubed is 8, 2 8s is 16, minus 2 times 2 is 4, times minus 9 is minus 36, plus 14 minus 6, so is 30. Take away the 36 is minus 6, but then if that was a plus 6, but it isn't, so it equals minus 12, I think, so it doesn't equal 0. So I'm now going to try minus 2. So we've had 3 goes at it, we're now going to try minus 2. P of minus 2 equals 2 times minus 2 cubed plus 9 times minus 2 squared plus 7 times minus 2 minus 6. Well, minus 2 cubed is minus 8, times 2 is minus 16. This is positive 4, 36. 7 times minus 2 is minus 14, and then minus the 6. So, minus 14 minus 6 is minus 20, minus the other 16 is minus 36. Minus 36 plus 36 equals 0, which tells us that x plus 2 is a factor. So once we've got that, we're going to look to divide the polynomial by x plus 2. And because it's a nice simple linear factor, we can do that synthetically. So, and also there's no gap in the thing, so we can write down 2, 9, 7, and minus 6, and draw a big line like that. And we are divided by x plus 2, so we can put a little minus 2 here. First thing you do, you bring the 2 down like that. And then you multiply it. 2 times minus 2 is minus 4. 9 minus 4 is 5. 5 times minus 2 is minus 10. Minus 10 plus 7 is minus 3. And minus 3 times minus 2 is 6. Minus 6 plus 6 is 0. So that's great. We have no remainder. And we shouldn't have a remainder because we know that x plus 2 is a factor. So the answer is 2x squared plus 5x minus 3. So that is the other factor. That's the quadratic factor. So now we have the linear factor that we found by using a factor theorem, and the quadratic factor that we found using long division, where we did it synthetically, synthetic division. So now we need to try and factorize this quadratic factor. So equals x plus 2. This is going to be, if it does factorize, 2x and x. 3 is a prime number, so your only options are going to be 3 and 1 or 1 and 3. So 3 2s are 6, and the 1, that's going to work, yeah. So I reckon a 3 and a 1. You want the 3 to be positive because that'll make a plus 6x minus x. So plus and minus. So now we know that 2x cubed plus 9x squared plus 7x minus 6 equals x plus 2, 2x minus 1, x plus 3. So now we've got a factorized denominator. We know that 5x squared plus 16x plus 17 over 2x cubed plus 9x squared plus 7x minus 6 must be identical to some a over x plus 2 plus b over 2x minus 1 plus c over x plus 3. Well, if we've got this fraction, which is the right hand side, and we want to try and form this into just one fraction, we're going to need a common denominator. The common denominator is going to be x plus 2, 2x minus 1, x plus 3. So what you're going to have to do is times this one by these two. So you're going to times this by 2x minus 1, x plus 3 over 2x minus 1, x plus 3 to give it this common denominator. You're going to times the second one by the other two, so x plus 2, x plus 3. X plus 3 over x plus 2, x plus 3. And the third one there, I'm not giving myself a lot of room, but you're going to have to multiply that by x plus 2, 2x minus 1 over x plus 2, 2x minus 1. That's going to leave you a 2x minus 1, x plus 3, plus b, x plus 2, x plus 3, plus c, x plus 2, 2x minus 1. All over x plus 2, 2x minus 1, x plus 3. So now going back from to the initial identity, as in the initial fraction, which we were trying to split into partial fractions. Remember that this is just the factorized form of 2x cubed plus 9x squared plus 7x minus 6. So 5x squared plus 16x plus 17 over x plus 2 2x minus 1 x plus 3 equals a 2x minus 1 x plus 3 plus b x plus 2 x plus 3 plus c x plus 2 2x minus 1 over x plus 2 2x minus 1 x plus 3. Now we almost get into something that looks manageable. So what the next step is clearly to multiply through by the denominator. So we're going to multiply through by x plus 2, 2x minus 1, x plus 3, both sides. So all that's going to happen when we do that is that they disappear. So you're going to have 5x squared plus 16x plus 17 is identical to a 2x minus 1 x plus 3 plus b x plus 2 x plus 3 plus c x plus 2 2x minus 1. Just about fits. Right, now again you've got two choices. You could expand all of this and try to get some coefficients to equate. So you would group it all in the x squared term and the x and the number, and you'd probably have, because there's x squareds and there's x's and there's a 17 to equate the coefficients of those, and there's an a and a b and a c, you would probably end up with three separate simultaneous equations for the three variables a, b and c. You can solve those using your elimination method, which we have learned. But looking at this, you don't have any repeated roots. It's going to be so much quicker just to substitute, because this works for any value of x. It's going to be so much quicker just to substitute certain values. So if we substitute a half in, we will be able to find b, because these two will disappear. If we substitute minus 3 in, this will disappear, we'll be able to find c. And if we substitute minus 2, this will disappear and this will disappear, we'll be able to find a. So that is what we're going to do. So if x equals, let's say, a half first. So we've got 5 times a half squared plus 16 times a half plus 17 equals, or is that, you can put identical to, but it equals. So a times 0 plus b, well, you've got a half plus 2, so 2 and a half, 5 over 2. And then you've got a half plus 3, that's 3 and a half, which is 7 over 2. Plus c, well, there's no c's either, plus c times 0, because when x is a half, 2x minus 1 is 0, so this whole term will be nothing. So a half squared is a quarter, so you've got 5 quarters, 5 over 4, plus, well, 16 times a half is 8, plus 17, so I'll just call that 25. So 5 over 4 plus 25 equals 5 over 4 plus 25 equals, so 5 7s are 35, 35b over 4, 35b over 4. So if we have 5 over 4 plus 25 equals 35b over 4, you're going to multiply that through by 4. So 5 plus 100 equals 35b. So 105 equals 35b, meaning that b equals 105 over 35. Now 35, 3 30s are 90, 3 5s are 15, so b equals 3, which means, so this part of the fraction, of the partial fraction, is going to be 3 over 2x plus 1. So b is going to be 3 there. Okay, now we go back to this and we let x equal something else. So if we let x equal minus 3, then we should be able to find c. So if x equals minus 3, so you've got 5 times minus 3 squared plus 16 times minus 3 plus 17 equals, so a is going to disappear because you've got x minus 3 will be 0, so you've got a times 0, plus b will disappear for the same reason because minus 3 plus 3 is 0, so 0b plus c. Well, you've got minus 3 plus 2, which is minus 1, and then you've got 2 times minus 3 minus 1. Well, 2 times minus 3 is minus 6, minus 1 is minus 7. So that is telling us 3 squared is 9, 9 fives are 45, so 45 minus 48, 16 times minus 3 is 48, plus 17 equals, well, that's 7c. Well, if 45 minus 48 plus 17 equals 7c, well, 45 minus 48 is minus 3. Minus 3 plus 17 is 14. So 14 equals 7c. So c must equal 14 divided by 7. C must equal 2. So now we've got nearly finished. You've got 2 out of the 3 partial fractions. So this c is 2. So the only one we are left with is a. If x equals minus 2, then that is going to knock out this term and this term because minus 2 plus 2 is 0. So if x equals minus 2, so you have 5 minus 2 squared plus 16 minus 2 plus 17 equals a. Well, you've got 2 times minus 2, so that's minus 4 minus 1 is minus 5, times minus 2 plus 3 is 1, plus b, well, as we've already discussed, we've got no b's because of this bit, and we've also got no c's because of this bit, c 0. So minus 2 squared is 4, 5 fours are 20, 16 times minus 2 is minus 32, minus 32 plus 17 equals, so minus 5 times 1 is minus 5, so minus 5a. Minus 32 is minus 12, minus 12 plus 17 is the same as 17 minus 12, which is 5 equals minus 5a, so a must equal 5 divided by minus 5, a must equal minus 1. So that should make the third thing. So we've now got all 3 with a being minus 1. 5x squared plus 16x plus 17 over 2x cubed plus 9x squared plus 7x minus 6 is identical to a over x plus 2, so that's minus 1 over x plus 2, plus b over 2x minus 1, so b was 3, so plus 3 over 2x minus 1, plus c over x plus 3, c is 2, plus 2 over x plus 3. So it was a hard slog getting there, but we looked at it. We looked to factorize the denominator. We started with the factor theorem, found something that made this thing 0. We divided by it. We found a quadratic factor. Then we factorized the quadratic factor. You ended up with these 3 things, and then you set your a, your b, and your c up. You tried to add the fractions together with a common denominator, and then we ended up multiplying through by the denominator on both sides, and then we substituted convenient values of x in to eliminate a's, b's, and c's, so we could isolate one variable in an equation. It takes a long time, but the process is it's accessible, I think, if you have those key skills.